This is a dystopic surveillance state. Now, I see a big turnout today. That's good. I know everyone is crazy about face recognition. It's been all the rage in the past few years. First among them were, of course, the Chinese, a very respectable dictatorship doing face recognition. They were the pioneers. Big in face recognition, an inspiration for all of us, basically. Some of you might have heard about the failed attempts of protesters in Hong Kong trying to hide their faces using mini projectors, projecting other faces on their face. This is, of course, false. They just use masks to hide their faces, but it didn't work, obviously. And not just, the big, respectable dictatorships, even new ones like Europe are building huge international facial recognition systems, and they're joining the club. And not just political entities, even corporates are using facial recognition. MasterCard, instead of using your credit card, now you can smile to the camera and think about how great it is that you can now connect your face to everything you purchased. It's really thrilling times. We have stores that require you to give your face in order to enter. Amazing. On a local note, it's a bit sad to see that here in Israel we're sort of not progressing with the times. We're not adapting to this new technology. Unfortunately, some forces are prevented, for example, putting facial recognition in the Pride parades just this month. Very sad. So, but I guess this will people will realize that this is stupid and we should all embrace this. And probably everyone here is thinking, this is such a great technology. How can I use it? It looks like it has zero negative aspects. So how can I use it for my own, small dictatorship or evil organization? And here I'm going to show you how to do it in Python. I'm going to talk about a library called face recognition. I really want to tell you that it's a great Python library. Unfortunately, it's not. It's a mediocre Python library. Unfortunately, I started working on facial recognition with JavaScript. There is a great library called Face API, .js. Everything there is .js. And it has everything. It runs in your browser. It does facial recognition, and it can tell you the gender and the age. You don't need to install anything. So it's really great. In Python, it's more complicated. You need to install all kinds of native dependencies. So not great, but we do with what we have. So just as an anecdote, research shows that most dictatorships actually prefer JavaScript for that reason. Most of them, 32, use JavaScript. Only 16 dictatorships run on Python, which is very sad and something we need to fix. And the other one is North Korea, uses Java, obviously. So I'm going to be using, for this talk, the biggest and most rich corpus of free faces that I could find. That is the photos of PyCon 2019. So if anyone who attended PyCon 2019 here? Okay, not a lot. So not a lot of opportunities to embarrass you, I guess. But it's still a few. Okay, so let's start with the beginning. I'm going to show you how to use face recognition for a single face, my face, obviously, because, the best looking one. So here it is, pre-pandemic. Here's the code. So we load the image file, which is basically my face file. We use a function called face locations, and we show the image. All right, so what face location contains is basically a list of coordinates. What are these coordinates? We have actually two sets of coordinates because we have two faces here. One is mine, one is not. Each face location is this one. Top, right, bottom, left. It's basically the location of the face in the image. If we zoom in on that specific area, all right, that's me again. But you can see it's a bit crooked. The face is a bit, to the side. The size of the image is arbitrary, 185 pixels on each axis. So not really, doesn't really make sense. So first of all, we want to normalize the face, or to sort of straighten it so it's straight, and to resize it to a regular size. And for that, we're going to use something called face landmarks. So most face recognition libraries use a standard called face landmarks, which is this nice image. Basically, they map each of the facial features onto a point. You have 68 points. For example, the tip of your nose is 33. It's right here. And your left ear is, I don't know, 0. Or, sorry, that's your right ear. So these are the points. So in order to straighten a face, what we want to do is to take point 27 and point 57 and make sure they're on a straight line. We could use the eyes if we wanted point 36 and 45, but for this demo, we're going to use these 2 points. Okay, so how do we get the face landmarks? There's a function, face landmarks, but again, this is a crappy library, so it doesn't give you the points. It gives you chin and left eyebrow and right eyebrow. Who needs that? We want the points, so we use a function called raw face landmarks, which actually gives me the actual points. So here I define a function called landmarks. It's calling raw face landmarks, and here I get 68 points, exactly what I need. These are the landmarks of the face, and now I can use them to straighten the face. All right, so how do you straighten a face? Using Python and not, the regular methods. Okay, we use something called affine transformations. And for anyone here who's studied a bit about matrices, this is easy. Anyone who didn't, never mind. But basically, each transformation on an image can be represented using a matrix. For example, the identity matrix does nothing. You can have a matrix for scaling, for rotation, for translation, which is basically moving the image, and other transformations, doesn't really matter. So how do we straighten a face? So I'm defining here a function called thumbnail, which will do lots of things, but let's start at the beginning. So we take the top point, this is the top landmark, and the bottom point, which is the bottom landmark. All right, these are the 2 landmarks that we showed. And we want to make sure that they're on the same line, right, on a straight line. So we calculate here using arctangents the rotation. We calculate a scale based on the length between those 2 points. So we want to scale them to all the faces to have the same length between these 2 points. This is the target size of the image. And then I define the matrices. So we have one matrix for, and here you have to use a bit your imagination. So, so I'm going to center the image. So I'm going to put the middle point between the forehead and the nose in the center of my, like in 0, 0, in the center of my canvas. Then I'm going to scale it up a bit or down, depending on the size of the image in the original, size of the face in the original image. I'm going to rotate it a bit, and then I'm going to position it again so that that middle point is in the middle of the resulting image. So basically, I define all these matrices here, and this is like the final matrix. I'm just combining, multiplying all those matrices, and then I can use pill, basically, to do a transform. I give it this sort of resulting matrix, and it transforms me the image without having to do all those steps one after the other. And now if I show the thumbnail, so we see that First of all, 300 on 300. The eyes are in the same size. And this line is more or less straight. So great. So now that we have that function, let's try to use it on some people. By the way, if you don't know linear algebra, I always recommend studying linear algebra, or as Stalin would say, study algebra linearit. This is the way he devised his own name, by the way. So take his advice. Okay, group photos. As all of you know, problems come in groups, and especially dissidents. So we have this group of scheming people smiling as if they know something that we don't. And we want to probably get a list of all the faces, you know, and pass them on to the secret police so they can be sent to special vacation. So how do we do that? We load the image. Again, we call the function landmark that we just defined, and we get 19 faces, which is great. So, but you see that some of the faces are crooked, some are in the back, some are in the front, but no need to worry. We have that thumbnail function that we just defined, and if we just call it, we get a list of all the faces ready to use for a daf kesher or for you know, anything else that you want to do with them. So this is great. We have a means to extract all the faces from an image. So now the next question is, okay, we have multiple images, and some of those images might contain the same photo of the same person. So how do we know if it is the same person? So we use something called the encoding, and here is probably the time to say that I'm not a data scientist. For me, an encoding is just a list of numbers, 128 numbers, which is a result of the face recognition algorithm. I don't care what it is. Some people might say that it is an embedding or representation in a latent space, but I don't care about all these words. I just need the numbers. So I'm gonna use a subset of all the photos. Let me show you the subsets. So I collected a few photos here, not a lot. You see that it has some recurring faces. Some have no faces at all. And we just want to extract all the faces from these photos, okay? Because the entire corpus is quite big. It has more than 1,500 photos. So we're going to start with this limited number of photos. And here I wrote a function called scan all faces. It's really not very interesting. It just goes over an entire directory and extract all the faces. And the next thing it does is also gives us the list of all the vectors of all those encodings in one big matrix. So we get this encodings array, which is 28, this is the number of photos, and 128, these are the encodings, the vector that represents a face. So these are all the faces that we decoded, 28 faces in all those photos. But now we need to say, okay, we can calculate the distance between each of these vectors, but what is a good threshold? I mean, what is a length that means this is a different person, and what is the distance that means, okay, this is the same person? So we're going to use a clustering algorithm called agglomerative clustering. We're going to use it for two reasons. First of all, my wife is a data scientist and she told me to use it, or else. The other one is that it really does what we want, which is it sort of divides the space into sort of bubbles that are of the same size. So I'm going to speed up a bit. We're running it. This is the x-axis is the threshold, and we see that we have some sort of sweet spot here around the middle. This represents a threshold of 0.5. So we're going to use this threshold and again running agglomerative clustering, and we can see that it detected the faces. So each row here is a different face or a different cluster. You can see we have 1, 2, 3. It really does a good job in detecting different faces. Now we can ask ourselves the question, who is the most photographed person in the entire corpus of PyCon 2017. And again, we run the entire clustering algorithm on that big corpus. And we find the biggest cluster. This is the biggest cluster. One of the organizers, Moshe, I don't know if he's here, but he's the most photographed person. All right, another question that is really interesting is men versus women in PyCon. And again, we can run a different algorithm. Here we don't have any solution in face recognition, so we need to go and find a different library. We use CV2 here, and we load a model for that. And it's basically the same, it's just a bit more messy and a lot more code, a lot more boilerplate code to run it. But we can run it and get a nice and not very surprising result. Okay. Another interesting result, by the way, from that classifiers, which are the best, like the ones that got the highest score on the feminine and masculine scores. You can see that the classifier basically finds images that are really good images, frontal with clear background, lots of pixels. So that's another side effect of that classifier. Okay, so I was told I only have 5 minutes, and that was 5 minutes ago. So I'm going to go and try to do the demo, and maybe it will work, maybe not. So let's see. What we will do now is connect this. This is basically live facial recognition, and maybe it will work. All right. So I'm going to switch here. All right. So this is an ear. Okay. So you can see my face. It's not really recognizing me. Maybe a bit. If I take down my glasses, though, okay, it recognizes me all the time. This is why Superman, by the way, doesn't wear glasses. But now I can go to the audience. Yeah. Any volunteers? All right. Let's see if it works. I can't see if it's recognizing you or not. All right. No, it doesn't find you in the corpus. Let's see. Is that you? I don't know. But this is 2019. All right, let's see. Does it work?
Yeah.
Yeah.
Absolutely.
It found you. So that's one. All right, let's try. Yep. All right. That's you, I think, right? So face recognition works. Be careful. Anybody else that wants to try? I'm going to be here for another 5 minutes. Want to try? Yeah, okay. Maybe I need to get a bit closer. No, that's not you. Maybe take off your glasses. Yeah, so the beard is a very good feature, but the glasses is a killer. I got the glasses 2 years ago, and without the glasses, it's 100%. So any questions?
How does it recognize between female and male?
Well, there are just classifiers. You have all those corpuses that are pre-tagged, and it just...
We actually don't know, it just tags.
Yeah, you have these models you can download for free. You can load them, and it just tags, female and male, and it gives you the confidence. It's not 100%. So if you look, for example, at the model and what it classifies as 50% male and female, it's usually just, random crap that it finds, not even faces or very blurry faces. But yeah, I mean, you can just download all those. There's also models for age prediction and emotion, face expression. So you can find all those, and it's pretty easy to use. Okay, so thank you very much.